So we turned the hammerhead into a luffing jib tower crane. We kept the tower and the swivel base.
Still able to slew.
And now we've got a jib that's about 4.5 feet long,
Right.
and it luffs with a windlass.
Same automatic brake system too. Listen for the clacking.
Okay, now lower it, boom down. We're going to shoot for 30 degrees. Hold on. Go up a little bit. Couple of clicks. Okay. Well, it's 40 degrees, but once we put, no, leave it. Once we put a load on, it's going to drop. So, for 30, go down to 30.
Yep.
My mistake.
More?
Yep.
Still?
Yep. Good. So the jib is at 30 degrees. We'll use cosine to compute the distance, and then compute the moment with the weight of the load, the skip, and the boom. What do we have counterweight?
3 bricks.
3 bricks, and the we're going to measure the distance from the pivot point, which is
This outrigger.
right. Hold that vertical. So we'll measure that later. So we'll compute the moment of the crane body, and the counterweight. Okay. So how many lines holding up the load?
Right now we have 2. We have one that's anchored into the jib itself, and the other one that runs over the top of this pulley wheel, which means it basically cuts the amount of force you need in half.
Because the crane is holding up the other half.
Right. But that also doubles the distance you need to wind it up.
Exactly. There's no free lunch.
None.
And obviously friction enters into it, but we're not going to talk about that now. So there's 2 lines holding up the load, or it's called 2 parts of line. What about what's holding up the boom?
Same thing. We have same kind of pulley wheel. One end connects into the crane body, and we have the other end that we use to pull.
Good. So one end connects right there. The other end goes over the pulley wheel
And into the windlass.
to the windlass, the load windlass. Okay. So luffing jib tower crane converts to a hammerhead.